do another round of awesome. Everybody's muted. So we're gonna get things going, get things started. Uh, just for everybody to know, the session will be recorded, and the recordings will be available through the Sunner's website and Sunner's YouTube channel later on. So today, at our first 2021 webinar series, we're going to talk about operational checkpoints, maintenance checkpoints, and all those stuff that goes into doing the correct preventative maintenance that goes into having a solar thermal water heating system, both for residential applications and commercial applications. And to get things kind of started, I have an interesting piece of information that I'm going to share with Bob, and we're going to take things from there. So there was a survey, O&M survey, that was done on 185 systems in Colorado. These are all active indirect systems in Colorado. And Bob, do you want to know what was the majority of the problem? They found 65 systems that were not working out of 185 systems. 65 systems were not working. And do you want to take a guess what was the reason why the majority of those systems were not operating correctly?
Either no power or fuse down.
Actually, no, it was the temperature sensor.
Oh.
That little pesky temperature sensor that goes off or gets disconnected, and the controller is not reading the temperatures anymore from the array, and everything stops working.
The sensor specifically, or the wiring?
They said sensor, temperature sensor, and mostly the mounting of the temperature sensor fell off. So that's where that problem started.
Gorilla tape doesn't work.
Gorilla tape doesn't work, exactly. And from that same research came another interesting piece of information, and that was almost 90% of those systems that were dormant or not active or not operating properly could be fixed with $500 or less.
That's very good. Yeah.
So, $500 or less, probably that was, just like a sensor mounting replacement, something along that line, and you could have had your system back on. So with that in mind, we're gonna, kick things off here with Bob. He's gonna go over all residential systems, what could go into doing a proper maintenance, when you're doing a checkup, when you want to take a look at a system. We're going to start from ICS, very simple direct system. We're going to work our way to all the indirect residential. From there, we're going to go into our commercial systems, talk about those, talk about the checkpoints, some of the experiences that Bob might have had on both, residential and commercial systems, things going off. And one of the main reasons we're doing this is because, as you can see in these pictures, we used to have people here, especially from our commercial contractors, the ones that had large crews, and we used to do on-site training for these people, so they knew kind of what was going on, what to look for when they go onto the site, and that's not possible anymore. At the same time, we realized that was quite limited, what we were doing, and this way we can reach out to more people and, share this information, all the experiences that Bob had with this different systems, and, kind of bring it all to everybody that could benefit from it. So with that said, Bob, please take a bit on a integrated collector and storage system, what you want to talk about.
Right, the integrated on the screen, that's also called an ICS system, or a batch heater is a generic name for it. You should check them once a year. All systems should be checked at least once a year. And then there should be an owner's manual for it. It's what we're checking on the ICS on the exterior is you check all the piping and insulation, make sure that there's no leaks, obviously no leaks on the valves. The pipe and insulation are good. Pipe insulation and jacketing, we recommend jacketing. Replace or repair jacketing if necessary. Make sure all the roof mounting hardware is in good condition and secure. Make sure the penetrations are properly sealed. check the glass and clean it if necessary. On the interior where the piping from the ICS comes into your primary water heater, check the city water pressure. Generally, it's supposed code wants it between 50 and 70 psi. An expansion tank is, we highly recommend it. Some jurisdictions required, is working properly and installed properly. Water quality is within our operations manual guidelines. Please look at that. All plumbing valves are working and not leaking. They're working order. Resident, you can see the unit on the left is a Servomatic. The glazing had been there for probably 15 years and broke. The replacement RICS is a copper hard CP40. It's glass, aluminum, copper internally. So not much to go wrong. We have racking systems for them. You check all the hardware. You're checking all that when you go on the roof. Hopefully the job was a quality job. It was all metal racking, no wood. The insulation, if not jacketed, recommend jacketing, but that's what you're looking for. You want to make sure it's kind of as it was when it was installed, and hopefully installed correctly.
And you will notice that we will kind of have this reoccurring pattern of stuff that we will mention, and it will keep coming up for all systems. You know, for this instance, the ICS system is a passive system, so we're not going to talk about controller, and we're not going to talk about sensors as much. But once we start getting to active system, you will realize, based on what I was sharing earlier, that sensor issue and checking the sensor wiring and all that stuff will come up again and again. It's the same thing with installation. We always check for installation for the piping, make sure the installation is intact, make sure it doesn't need new jackets, replace it. Try to protect that heat, basically, that you're getting from your system as much as you can, before you get into the main boiler. And this is now an active system here, a direct active system. So
these systems are primarily in areas that experience no freeze. The potable water that comes from the city or well or wherever you're getting your potable water is what's directly circulated between the tank and the collectors. What you want to do is check. I like checking these monthly. You do have a controller. Hopefully it's a digital R controller. Check and make sure that the sensors are reading. They're reading, for one. That's indirectly sensor related, and they're reading per your manual what it tells you it should be reading, meaning one sensor is not extremely high versus low. It's all in the manual and in the owner's manual. Direct system annual checkups. The monthly is like a 5-minute deal. Annual is a little longer, could be owner or service tech. All the pipes, valves, working condition. Insulation, working condition. Go back a second, would you?
Sure.
Because a lot of this is repetitive for the all systems. Roof penetrations, sealed. Any valves on the roof and anywhere in the system are good. City pressure, please check that. Expansion tanks required if necessary. Generally, we recommend it. Mixing valves, check all the parts. Should be clean. I like to tell people if they want to clean the top of the tank before you get there, so you don't get, have an allergic reaction to dust. All right. So the checkup annually, you're looking at the glass. You're looking at clean it if necessary. The pipe insulation on the roof, mounting hardware. Make sure that nothing is out of place. Internally, again, you're looking to make sure it's a clean. Hopefully, it's a clean installation. This is pretty nice. It's not all over the place. The insulation, if there's gaps, fill them in. If there's mice or something chewing, you may have to jacket the internal insulation. Make sure the wiring, the sensor wiring is protected on the roof, and it's reading correctly at the controller. The most problems, as Amir mentioned, are the sensor wiring. With two issues with wiring is the connection between the sensor and the thermostat wire you run is not waterproof and it's failed, or the wire itself, the thermostat wires run on the copper pipe, or it makes contact with the copper pipe where the pipes go through the roof. That's a fault that you can usually see on the controller, but verify that. The system diagram, flushing the system out, flushing the tank drain yearly from the tank drain. With a direct system, you may want to flush the panels with valve number 11. You can push water through the entire loop and just flush it out for any minor particles in there. So that would be the annual service on these. Again, the resident, the only thing with direct, if the direct system is installed in an area that old system or even new ones that are in a potential freeze area, verify, confirm all the anti-freeze programming and components that might be incorporated into the system. Again, we don't recommend these in freeze areas because Murphy's around and he kind of can cause systems not to work, and then the collectors are prone to freeze. So, but if you do have one, verify all the freeze protocols for the system. So now we'll go to indirect there.
We're moving on to first indirect glycol systems. And Bob, just to kind of circle back to the direct system, other than the wire, for the sensor or the sensor itself, or the placement of the sensor being the cause of the issue, what would be the second most common thing that would go wrong with a direct system that you have seen so far, especially from our Hawaii market?
For the solar part of it itself, someone has maybe in the past turned off the water to the house and not deactivated the pump. So that will, if that's happened a few times, that could cause the pump to fail. And if you're monitoring it monthly, you should be able to catch it monthly. If not, when you will catch it is usually when you're electric, in a single tank direct system, your electric bill will go up. So the owner usually gives you a call and says, my electric bill went from X to X plus double X, and
that's
I need a problem. And then you could ask them with digital controls, to either do FaceTime. I do a lot of FaceTime with people, or just give you the readings. Just tell them that they're afraid. Just tell them push that down arrow only. Just touch it. Don't touch anything else, and you could get an idea based on the time of day they do it what's happening. So that's the second most common problem. Third is the control's not plugged in or the power's not there. That's common also. Rare, but it's as the list goes, it's the highest one is sensor wiring, and mostly the wiring, 90%, only very small sensor failure, direct sensor failure. And then the issues are down below that. It's like climbing the mountain and sliding all the way down. There's the worst one, and the next are quite a ways down. So indirect systems are systems that generally use a heat exchanger to transfer heat from the heat transfer fluid to the potable water. This is on the screen as a indirect glycol system. Monthly check, same thing. Check the functionality of the system, check your control, make sure the solar system is heating the water, the solar system part. Check annually, that's a little more. Flush the tank from the bottom drain, check the anode, replace per use and care manual. We recommend you have all the manuals with you, or the owner has them for you. Check the system pressure. These are pressurized glycol. Check it early in the morning or after dark to make sure charge is according to the system's operational manual. Again, on the roof, check points of penetration and mounting for seals. Check the collector piping and valves for any signs of leaks. Check the control and sensor wiring. Make sure that it's reading properly and there's no fluctuations in readings. That's usually a connection issue. Pipe insulation again, and that's the most common external roof issue, is the pipe insulation has not been, it's been painted and the paint's worn off. So we don't recommend that. The first recommendation is jacketing, and then the integrity of the collector. Make sure the glass is clean. Clean it off when it's cool. Don't do it when it's 120 outside. That's just wait until evening or in the morning. The roof, you can see a roof system here along with a pool system. Usually indirect glycol systems have a primary heater. So the solar tank is feeding that primary gas heater in the picture. If everything's working, you never have a lack of hot water and the gas bills are always low. So whether it's propane or natural gas. The diagram you see how, again, the owner should have our manuals are all online. They should have that manual, or you should have it as part of your annual checkup to go out there, have the references so you can see what's happening. You're going to, again, check the glycol pressure is the main thing, and flush the bottom of the tank. We recommend on any anode changes for all these anode tanks is check it the first year and then check it every 2 years. Soft water will degrade the anode in under 3 years. The anode is essentially not working to protect the tank. So that's really important.
So especially now that we're talking about this residential systems, depending on, I mean, obviously it's different from every market depending on different programs that were out there, but we all know that on every market that there was some sort of an incentive program. There are a lot of systems that were installed not with the best intentions for the homeowner, or not with the best intentions towards saving the maximum amount of energy, and they were like basically meant to make the contractor the most amount of money. And most of those contractors, they were not in it for the long haul, so they're not around anymore. They're not providing service on their system. But the point is that this essence of the system is already there. So with very little to almost, no cost to the homeowner, they can have the system, uh, back working and benefit from it, knowing that usually these residential systems were designed to meet at least 70% or higher of the load. So that's something to consider and have in mind, that there are a lot of systems going to be out there that can be, back online, saving the homeowner a lot of money depending on what they're using, and it doesn't cost them much. So, sorry, Bob, please go ahead.
Oh, that's
back
okay.
to
No, that's
indirect
good.
drain back.
No, we've got indirect drain back again monthly. Try to have the owner, obviously our technicians aren't going to be out there every month unless the people want to. Monitor it based on functionality. Make sure the solar system is heating the water. That's in the operations manual, in the installation manual, in the solar control manual. It tells you what to look for. You just want to make sure you catch something early. So, I mean, the most common would be, that, let's say the pump's not working. The roof, you don't know that, the owner, he pushes the control and he sees it's 210 or 20 degrees on the roof, and it's 70 degrees in the tank. That's a thing to call you, because he's not going to, or call the technician. Generally, people aren't going to fix it themselves. So monthly, that helps catch it early, avoids, just like a car, you drive with a flat, if you keep going, you'll have, suspension issues or worse. So we just want to catch them early.
This is just like any other water heater or any other system that you have. We recommend this monthly checks, and we know for a fact that the majority of homeowners out there are never going to, take the time to look at the system. But that puts more responsibility on the contractor or the professional who gets a chance to look at the system, to make sure that, hey, even if the homeowner forgot to check the quality of, for example, in the indirect glycol system, the heat transfer fluid, and that hasn't been checked for many years, maybe now that I'm here, I'll take the time to, pull out that test paper and do a quick check and make sure it's not acidic and it's not eating through like all my coppers in the system, stuff like that. These are very simple, very easy to do preventative maintenance and save thousands of dollars for the homeowner. This takes a little bit of time and knowing what you're doing. A lot of time the problem is the person who shows up to do the service is a plumber with all the experiences that a plumber has and very little knowledge of the solar thermal system side. So just more responsibility for us to do more and more training for people, basically.
Drain back systems, again, annual checkups. Check the standard stuff, integrity of the collector, pipe insulation, roof penetration, and seals. Check for signs of leak at any of the plumbing connections, either on the roof or in the garage or maintenance area. Check the fluid, the heat transfer fluid in the drain back tank. Inspect and refill as the manual would tell you. That's kind of the number one thing. If the system's not designed right, it's years before you have to do it, but you want to make sure there's enough, the fluid is at the design level. Inspect the tank's anode, replace as per the use and care manual. Flush the bottom of the storage tank. Let's put a hose on it, run it for a minute or less even. And then that does two things. It clears out any particles in it, makes sure the drain works. Indirect systems are again, you're looking for anything that's unusual, out of the ordinary, which would be leaks or low fluid, and you want to make sure that the system's pumping properly. It's heating the tank. Drain backs advantages for both freeze areas and high temperature areas. It works both very well. They need to be installed properly so that when this pump shuts off, the fluid drains back into our reservoir, either here or the tank. There's whatever drain back reservoir you have. So East Coast, a lot of northern climates, East Coast, most of the people now, the installers that are doing this, have glycol in the drain back fluid. They don't want any issues when it gets 20 below zero. Water still works if everything's, the pump shuts off at night and everything drains, it's still fine, but people, again, Murphy's there. Once in a while we've had, we've seen the result of a pump running at 10 below zero. Wasn't pretty, it was a large commercial pool job, so that's why they use antifreeze. But again, monthly and yearly inspections will most likely catch these issues before they happen. So
as we're wrapping the residential systems, now, of course, the differential controllers that we have, especially for a residential system, based on what was available on the market, they're quite limited. We are hoping that within the near future we'll have more advanced versions of our residential differential controllers that can actually be monitored online by the homeowner and some other monitoring system, so they can catch some of these stuff that you're mentioning, that you need to do a monthly checkup. Hopefully in the near future the homeowner will be able to look at their mobile device on their app and see if the system is properly working, if the with the temperature of the roof and the temperature of the tank, everything is working properly and the heat is being actually transferred to the tank and whatnot. With commercial systems that, as Bob said, we're going to get into those really quickly here, but as Bob said, the larger the system, the damage is caused by a failure in the pump or something along that line could cost more and more for the system owner. So having an online monitoring system, and that's some of the things that we see a lot, especially with our East Coast contractors. I see a lot of great monitoring systems that using thermal grid, they adopt it into their commercial systems. And that's actually a great preventative maintenance tool, because you get early alarms, you get heads up when something is not working, when you're reading too high of a temperature, when your pump operation is fluctuating, you get all these alarms and heads ups, and you can send somebody there to fix it before you have that big freeze damage or something along those lines on your hand. So that's something to also consider, that yes, the initial cost will go up, but it will potentially save you a lot of money by enabling you to do preventative maintenance along the line. So we're going to get into direct systems for commercial systems.
Right. The direct system is, again, for areas that experience no freezes, Caribbean, South America, Central America, as far down in basically latitude 20 and the elevation's low on that part of the world. Hawaii, the Pacific islands, that area has commercial direct systems. There's sort of, again, no freezes, and water quality could be, you have to check that. Volcanoes add acid to the rain, and if that gets into the water supply, that can do a number on copper. So just have to watch all that, where it's site specific. You check the operation again. Solar is optimizing the input to the water load. You want to check. These are annual. The monthly, I think, is elusive, because if the maintenance people don't know what they're doing and the owner's not there, the only thing, again, Amir mentioned was monitoring, and I'm going to mention something for SoCal that might help. But check the roof integrity, the racking, the piping, the insulation, all that should be up to what it was when you started, when it was first installed. The jackets, if they've slipped, put a new jacket on.
And Bob is mentioning mounting and the roof mounting equipment, especially with direct systems, because of the areas of the world they get deployed at. Those areas, most of them are very prone to experiencing hurricanes and very high-speed winds and stuff like that. So it becomes more and more prevalent for the integrity of those mounting systems to be intact, especially if you went through a hurricane season. Somebody needs to get up there, make sure that something is not pressing against something else, and creating all the shear points and break points. So that has to be checked upon, and make sure everything, as Bob said, is as per what was installed on the first day, that passed the code, the local code, proved it. Everything has to be in that level of integrity.
Right. Yes, because things weaken, you may have to reinforce it. You want to, check the same kind of things that residential flushing out systems. You can flush the collector array if you have the right valving, similar to a tankless water heater. If you do any of those, you flush and clean them, but you can just, usually if the water quality is good, just flush it with the city water. This is a diagram. They're very simple. They pump the water out of the storage tank through the collectors and back to the storage tank, and that occurs over and over again. And then I think on this, this system's direct feed, so the designs are simple. You have a preheat storage tank that feeds. These are systems in, I think, Hawaii. You can see the skyscrapers and the clouds and the green outside the city. But they're all mounted low. These are low tilt, which if you're closer to the equator, it helps. You want the panels, if you come across panels that are tilted at less than 5 degrees, or we recommend 10, it needs to shed water, because a lot of these places they have annual rainfalls that are higher than SoCal for sure, and water will pool on there, dust will stay on there. So just hopefully you can get them at 10 degrees. That's the minimum we want to see. That should avoid most trouble. There's consolidations you make with the architects and homeowners associations, etc., but we want to get them at 10 degrees.
We've seen it with large PV arrays. They have all these washing machines that they install to keep the array clean. So it's a similar concept. Basically, if you have anything obstructing the path of sunlight to your array, the efficiency of the array will diminish over time. So as Bob said, if you have those pools being created on the surface and dust gets in there and gets muddy and then dries up, basically that area of the array is now not collecting any solar energy. So keeping the array clean, as simple as it might be, it does have a lot to do with the performance of the collector itself. So we're going to jump into indirect glycol system, and for commercial system, we have several of these, Bob, and we know
they're a little bit different when you have pressure involved.
Yeah, these are larger systems. There's plenty of them out there. Indirect glycol, they're pressurized. There might be, 10 to 100 panels. There should be an owner's manual for the system or an operation manual. If not, we recommend that one be constructed for the owners and either for you or for, at a fee to the owner. Anyway, you want to check the system operation, make sure that it's heating the water properly. You want to make sure all the arrays or banks of multiple banks are heating equally. So that one bank isn't 250 degrees and the other one's 80 degrees. Make sure the flow is right. You can do that with thermal imaging cameras or by touch. Check the transfer fluid. You want to check pH and the freeze tolerance using a refractometer, just to make sure that what we've had happen, people add water to the system, and then when we finally get a freeze, there's little or no glycol and the system's freezing. What happened? So check the roof integrity. Make sure if anything just looks disheveled, then that's something to note for the owner. If that's all he wants is an inspection. Check the heat transfer pressure in the early hours. And then the expansion tank you want to check to make sure it has proper charge. Most expansion tanks in commercial jobs do have an isolation valve. The handle may be removed, so you should have an isolation valve in the boiler drain so you can depressurize it, check the air, recharge the air in it if necessary, and then bring it back online with with no loss of fluid or very little. Flush the array. The plate side of it, if you're using an external heat exchanger, those plate and frame heat exchangers work very well, but they're subject to water quality, both dissolved and undissolved particulates in the water. So you flush it similar to, again, a tankless water heater, if you're familiar. If commercial systems have anodes, inspect them and change them as necessary. Again, there should be an operation manual. Hopefully there's a checklist in that manual. If you have to construct one, once you get a checklist, then that's one-time thing. You can keep it for your own files if you're the service tech for the job, or if the owner wants one, you can charge them for it or put it in the service call. Indirect glycol systems, we have options are unpressurized tanks with a pump, a complete pump station that circulates the water between the unpressurized tank, that's like your storage, and then it circulates from the panels, and then it transfers the water, the heat, from the storage tank to the building's hot water. Usually that's what we call it's a injection or a positive push system into the hot water system. So through the pump station. The advantage of that is it's not a pressurized tank, and it doesn't interfere with the pressure or flow to the building. So the installer never has, if there's an issue with pressure or flow in the building, it's not the solar's fault. So and you can do that on a large scale, small scale. I mean, one tank system, small storage tank, you can do injection. If, with the new codes, they require 10 or 20% solar, you can inject into a 2-inch line with a 3/4-inch line and comply with all the codes and not interfere with the pressure or flow to the building at all. Because I don't know, for some you've probably experienced it. The solar is the first thing that's in the bullseye, and this eliminates that. They're very, once you get them installed, they're very simple. This is glycol. Again, check the expansion tank, I like to check operation of valves, make sure they're working once a year, just turn them on and off. Make sure all your valves are working.
So So here's another thing that I want to reiterate that we're talking about with Bob here. We talked about manuals a lot. And there's a lot of parts and components, especially with an indirect glycol system like this. There's a lot of parts and pieces that goes into this right here. There is going to be the plate frame heat exchanger, several pumps, the differential controller valves, a lot of stuff. So if the contractor or whoever's installing the system decides to put this together on site themselves, they are more than likely required to provide a complete set of documents about the system operation and how it works and how they can shut it off, how can, how troubleshooting on it works, and so on and so forth. If they choose to go with a pre-manufactured solution, a pump station that is manufactured by Sunner, instead of putting everything together themselves, then with that part of that product package is that product manual. So everything related to it, all the operation, everything that has to be explained to the final system owner is already part of that manual that can be handed to the system owner without the contractor having to figure out system-specific, parts-specific manual and write it down from scratch. Obviously, there are additional instruction that you can add to the current manual of a system based on the specific design of the system that you've done. But the difference is just having a product or having a bunch of parts and pieces that you are responsible for. So with this, something like this, here you have a example of a smaller version of our solar station XL being deployed on a pressurized indirect glycol system. So all those parts and pieces to operate these 3 tanks and this array is basically in this one piece of equipment with one user manual, one manufacturer to call in case they need a part or a piece for it, and everything is concentrated into this one single package.
Right.
So that's another thing to keep in mind, especially on large commercial system. It matters. I've seen some incredible, especially again from our East Coast dealers. Some of them, they do really, really nice commercial drain back systems, and I've seen the installation that they do and the amount of documentation they prepare for their customer, and it's very detailed, very great to have for the customer. But I bet it takes a lot of time and energy goes toward preparing that kind of documentation. So by adding a manufactured product, not only you save time and money on the putting the product together yourself, but also everything else, the support document that goes along with it already has been prepared for you. So with that being said, we're going to move on to our next design, the industrial drain back system, which I think if you're thinking about it, frankly, we like drain back the most for commercial systems whenever it's allowed, because
drain back addresses 2 issues: freeze, cold and hot. So the best example is a school. Not right now, but schools are usually vacant. The load drops during the summer, and you have a super system up there that's, if it's pressurized, you have to deal with that somehow. With drain back, it turns off. It shuts down when it reaches max temperature, and it drains all the fluid drains out. The panels are just, they're sitting up there. They're designed to do that. So that's the advantage of drain back for commercial systems. We don't know, maintenance, people can just turn it off and don't worry about it. They don't have to. I know one where it just glycol for a pool, and every time the pool guys do something, then the solar guys have to make sure that they're doing it correctly because it's a glycol system. So there's real advantages to drain back. Again, with an indirect system, drain back, check it annually if possible. Operation, make sure the inputs toward the water heating to the thermal loader, it's working. Check the heat transfer fluid and the fluid level in the drain back reservoir. Could be pure water, could be a mix of propylene glycol and water also. Check the roof integrity, insulation, inspect for leaks, replace jacket insulation if necessary. That's all. It could, especially with the high winds we had here in Southern California, 90 plus gusts here last 2 days, which can do some rearranging of things on the roof. Want to check it all out. Flush the array The plate exchanger, if it's used on the potable side, the way to check it is if you have a flow meter, you check to make sure there's adequate flow. If there's with temperatures, you can make sure the heat's being transferred from the solar panel side to the potable side via temperature. So, and if necessary, flush it with there's products out there through plumbing supplier boilers to flush exchangers of deep scale. Check the anodes. The system previous you saw used 3 large storage tanks. Check the anodes in those and replace if necessary. Indirect systems. Here's one we have which uses a non-pressurized tank. It's
it's a heat injection.
It's pumping. This is pumping directly out of the tank through the panels and back. So it's it's a direct line side system. The water is directly pumped through it. And then on the load side, which is the water potable side, we have coils in the tank that absorb the heat from the stored water. And then to avoid, again, that pressure and flow to the building, we have a system that's thermostatically controlled. It's a pump and a controller that circulates into the main line feeding the heaters. So you just want to make sure all that's working if you see that type of system. We're getting in a little design, but you just want to make sure the heat, one, is being collected and then transferred to the end use so it goes down the drain.
Yeah,
this is a nice work. This is what you're striving for and you hope to see in systems. Everything's labeled, nice clean on the roof. Again, you're going to be on this system. You don't have to worry as much about wind loads because of tilting, but you still want to check to make sure everything's secure, leak, and waterproofing is correct. Nothing's out of the ordinary. If it is, bring it to the owner's attention, or if you have like a contract, just fix it, note it, what you've done.
So we're going to jump into the fun part, Bob. We're going to start asking questions. Why don't I have enough hot water? You get that call, what, 10 times a day?
We get a lot of them in wintertime. We get a huge number of them.
So what are the most common causes? Where are those calls coming from? Is it solar's fault? What's going on, Bob?
Well, it's usually the sun's not shining and it's raining for a week. Okay, so that's the problem.
Yeah.
The sun's not out today. So, and you want to first, if you get the call, if you're getting a call, determine from the owner, or if you know what is a single tank system, whether single direct or single indirect. You want to make sure that you figure that out. If it's a single tank system, so the storage tank is the water heater, the most common problem is the element is not receiving power. If the system is a 2-tank design and they don't have enough hot water, check the primary heater, water heater, either gas or electric. It's either with natural gas, it's a pilot light not working, or propane pilot light's not working. Check the use and care manual that is specific for that water heater. You may have had a wind event that blew off the vent cap on top of the roof, and the wind was enough to blow the pilot out. So this is if there's a standing pilot. With electric water heaters, the most common issue is it's an ECO safety switch breaker in the thermostat is tripped. And again, consult the use and care manual in that tank on how to reset that switch. What the ECO does is break the electrical power to the elements. So when the weather is with a 2-tank system, if you have no hot water with an electric water heater, that's usually the primary thing, and secondary is thermostat or the element is not working. So it's the primary heater primarily. Why don't you have enough hot water? The element may not be working in a electric water heater due to the main breakers being off. Somebody may have turned them off, never turned them on. The solar's been working for 8 months. You never used a spot of grid power. All of a sudden, the weather changes. The time, if the electric element is controlled by a time clock or what's called a little gray box, maybe it's off, or the power failures have caused the time to go out of sync, and so it's coming on at the wrong time and you're not getting enough hot water. It's not heating when you want it to, so check the little gray box. Again, in the water heater itself, in the tank, in the solar tank, or the electric water heater, the element's thermostat ECO is tripped. And again, follow the directions in the use and care manual to set it. Or in the tank, again, the thermostat or the elements are faulty and need to be replaced. In many systems, there's a thermostatic mixing valve on the outlet of the water, either from a single tank system, which is common, and the mixing valve is there to prevent scalding, and it may have failed due to hard water issues usually, and it's now not mixing the hot and cold. It's like a shower valve, as you probably well know, and it's mixing all cold. It's allowing cold water through, no hot. So everything's working except the hot water in the tank can't get to the fixtures, can't get to the shower or to the sink or wherever. So those are the main reasons you have no hot water. Usually pretty simple, and a lot of them literally because the sun's not shining and the people have the power off to the elements. What if
you have too much, Bob? What if
too much hot
water?
Well, the issue is primarily due to the solar thermal water heating part of the system overperforming. Meaning, it's kind of we're going to assume that's what the question means. System was either oversized for the particular project. For two older people, it's too much. Usually, we've had those calls, or the load may have changed since the time of design. For instance, the number of occupants has left. That's something that, there are fixes for that, but you generally, unless the people want to do it themselves, you get a licensed contractor, solar technician out there to rectify the issue. I mean, in some cases it means removing a panel or blocking a panel off because it went from 6 to 2 people. I mean, now we're seeing it go backwards, so usually we're not seeing these issues with too much hot water, but in the past, it's been everybody left the house, the last 2 people in the house are not using as much hot water, and that's when we get some issues occur because of too much hot water. So again, it needs to be inspected by one of your technicians.
Awesome. So I'm just gonna change this. We're gonna go to this slide that says Q&A, which means at this point, if anybody has any questions, I don't know if anybody typed anything in for Jessica.
I have one more. We talked about monitoring that can pick up a lot of this. In Southern California, the SoCal Gas, which there's a lot of solar systems hooked up, they have a program to monitor their entire water heating system, and it's sponsored through the gas company. It's called SaveGas.com, and if the owner decided to put that system in, they can have additional temperature sensors put on the solar system, and then the system can be monitored through SaveGas.com. The owner can see the app, and you, if you have the technician, can have access to it via owner's permission. You can watch, you can see the system, you can see if the tank is heating. It's indirectly you're seeing if it's working. Tank's heating up, cooling down. Okay, it's working. We had one cut. The reason I know this, one of our clients has a customer with it. He has the sensors placed, and all of a sudden the tank never cooled down. You know, it's an 800-gallon tank. What's going on? He went and called, and they found out a plumber was there, and he forgot to change the bypass valves. So he was able, go back out, turn the valves. He's all good, and it's just by him being able to look at it. So it's a system that you don't have to install. You can have access to it, and it'll help you monitor. You monitor the solar system, and if you're into the whole water heating design and installations for the apartment, you can monitor the whole thing, and you can catch glitches before they happen. Again, it's through the utility, which gives it a little bit of credibility. It's working well. The owner, and also there's alarms that can be programmed. So if you can have it set for, if this is this, then that'll happen. You'll get a text. So it's one method, because monitoring, there are solar monitoring systems, as Amir mentioned, thermal grid, that monitor the entire solar system, which are available. But this is maybe something that's more palatable to the owner if the monitoring system hasn't been installed. When the system was installed, it's a little more difficult to get a monitoring system in there that that works. You have some networking issues, and with this, that's all taken care of. You don't need a IT guy monitoring it. It's all done for you. So that's one plus that we found just by accident.
There might be similar ones available through other utility providers throughout.
Yeah, it's indirect. You're not checking flow rates or energy production or any of that, but you're seeing temperature differences that by default, oh, I got a problem.
Awesome. So with that, seems like we don't have any questions coming our way. I think this was pretty much, going over a lot of stuff that people were pretty familiar with, just kind of, summarizing it, collecting it in one place, going over it, making sure that, it's the beginning of the new year. There are a lot of residential commercial systems out there that all they need to go back into operation is a little TLC, and hopefully they will get it in 2021. So again, if anybody has any more questions, we'll be here for the next few minutes. If not, thank you so much for taking the time and joining us for this session, and we'll look forward to the next one of our seminar coming up in a month or so, again with me and Bob. So
we hope you enjoyed it. If you have any suggestions, please email us. We always put that into our webinars, because that's how we find out what's going on out there, what needs to be addressed. Input's always appreciated.
Thank you so much, Nick, for taking the time. Our pleasure. We're glad you liked it. As Bob said, please send us anything that you guys, if you're getting feedback from your contractors on the field, people out there, they're asking questions that we're not hearing necessarily. Please let us know. If you're working with engineering firms, there are certain design areas that they're struggling with. For instance, I know myself, I've been working a lot with engineers here in California on Title 24 stuff, because it's something new, it's something that they're working on, and it's not familiar for them. But if anything, please let us know. Thank you so much for taking the time, everyone. Mike, thank you. We appreciate you guys so much, and we're here for anything that you guys need.